Try this again. It crashed on me. This is part of the reason why I'm not really wanting to do videos. I'm having a lot of problems lately. The 6.1 graphs of exponential functions. This is the mother function y equals a times b to the x. And we're going to do kind of a funny looking table. I'm going to let x be two things, 0 and 1, and I'm going to get back weird things. This will give me a times b to the 0 because I'm letting x be 0. Now, anything to the 0 power is 1, so I just get an a back. 0a, funny, isn't it? Because the grid is in numbers, we're just going to have to label it 0a. If I plug in 1, I have a times b to the first power, and b to the first power is just b. So I get back ab. So I also contain the point 1 comma ab. Now, exponential functions that grow will always look like what I'm drawing. They will flatline on the x-axis unless the transformations happen, and then they'll grow pretty sharply as you move right. And you got that little note here about what things always contain. But just plug in a 0 and 1 and you're good. The domain of this thing is that it runs left forever and right forever, and the range is that you get redonkulously close to 0, but you don't actually touch this line right here, and you rise to infinity. Now on the mother function, the x-axis is functioning as a horizontal asymptote, and its equation is y equals 0. Horizontal asymptote is a line that you cannot cross as you approach either positive infinity or negative infinity. Alright, graph 4 times 2 to the x. And I don't know why I didn't put a table on here, but I didn't. Just plug in a 0 and 1 and go with it. If you plug in a 0, you have 4 times 2 to the 0th, which is 4 times 1, which is 4. So I contain 0, 4. Remember, it contains 0a. If I plug in a 1, I have 4 times 2 to the first, which is 8, because 4 times 2 is 8, kids, which is not on this grid. This grid only goes up to 7. The rest of it comes from knowing the shape of Mom. She's going to flatline near the x-axis. The x-axis on this one, since it hasn't been shifted up or down or left and right, is functioning as the horizontal asymptote. The domain is negative infinity to infinity, or if you like set builder, all values of x such that x is an element of the real. The range is 0 to infinity with a parentheses on the 0. Or if you like set builder, all values of y such that y is bigger than 0. Moving forward with our lives. Here is your form, y equals a times b to the x minus h plus k. A is still the initial slope. In fact, if you will look back, you will see that we actually rose 4 and ran 1, just like that number right there. H is the horizontal translation, shifts you left and right, opposite of the sign. And k is the vertical translation, is also the equation of the horizontal asymptote. Alright, let's do one of these with transformations. I have 13 minutes till class. Graph 3 times 2 to the x plus 3. This would be a left 3. So I'm going to shift left 3, and you need to start showing these. It makes sense on these. Because what happens when you do the down 4 is you get the horizontal asymptote for free. This is the horizontal asymptote, and it's y equals negative 4. And it should, actually I'm not going to say it should be drawn, it has to be drawn. It's not a you may, it's not optional. You have to draw those things. Otherwise you'll cross into territory you shouldn't cross into. Domain, I can tell you right now, since this is an exponential function, is negative infinity to infinity. Let's see here. Now, you'll notice I've got this arrow drawn here. This is telling me the centering x value. It's negative 3. If I subtract 1, I'd have an x value of negative 4. And if I add 1, I'd have an x value of negative 2. So there's the 3 things we're going to use to make our little table here. And we're just going to plug them in. I'm going to start with this one, because this one always works out well. It's 3 times 2 to the negative 3 plus 3, and then minus 4. So if we do negative 3 plus 3, we get a 0, right? We have 3 times 2 to the 0, which is 1 minus 4. We get a negative 1 back. So I contain the point negative 3, negative 1. If I plug in a negative 4, I would have a negative first power. 3 times 2 to the negative first power, and then minus 4. And it's going to get a little ugly here. You know, think about 2 to the negative first. That is the same as 1/2. because we shift that number to the denominator to make the exponent positive. 3 times a half is, 1.5 if you like decimals. Take away 4 is negative 2.5. If you like fractions, it'd be negative 5 halves. So I contain negative 4 and then negative 2.5. If I plug in a negative 2, negative 2 plus 3 is 1. I have 3 times 2 to the first and then minus 4. 3 times 2 is 6. Take away 4, I get back a 2. So negative 2, 2. And you can kind of see the shape of Mom showing up there as she should. Now pay attention here. You see that? 1, 2, 3, 1. Still initial slope. Range on this thing. We have a low y value redonkulously close to negative 4. Rises to infinity. We're going to change this one up a little bit. I'm going to make this what we call decay. This will be a decay. It will not be a growth model. It will be a decay. So I'm going to put a half in there. The transformations that are present are there is a vertical reflection. That comes from that right there. I see a right 4. And I see an up 3. That's what I see. Okay? And she is decay. The b value has changed. So instead of rising as you move right, it's actually going to get smaller as you move right. Now let's make a little table here. Right 4. 4 is the center value. Add 1, you get 5. Take away 1, you get 3. Plug them in, okay? So we have negative 2 times 1/2. Let's do the 4 first because 4 minus 4 is 0. And add 3. Again, this is 0. 1/2 to the 0 is still 1. Negative 2 times 1 is negative 2. Add 3, you get 1 back. So I contain 4, 1. And I'm kind of jumping ahead here. I had a right 4. I'm trying to beat the clock here. And an up 3. That up 3 was the big one because that's my horizontal asymptote. I cannot cross that thing. Alright, if I plug in a 3, 3 minus 4 is negative 1. So I would have negative 2 times 1/2 to the negative first power, and then add 3. So if you think about negative 1/2 to the negative first power, that's going to be, sorry, it's positive 1/2. That's going to be 1 over 1/2, which is 2. So negative 2 times 2 is negative 4. You add 3, you get negative 1. So I contain 3. I feel like I've made a mistake here somewhere. Yeah, I did. That's not 4-1 now, is it? 4-1 is right here. Ugh. 3 negative 1 be right here. And I guarantee you that, well, there's your falling of 2. Let me say that. I need to plug in a 5. Right? So if I plug in a 5, 5 minus 4 is 1. I have negative 2 to the 1/2 to the first power, add 3. So that's negative 2 times a half, which is negative 1. Negative 1 plus 3 is 2. So 5, 2. Now the shape of this one, it's got two things going on. It's decay and it's negative. It looks like that. And make that a little better. It's kind of an ugly looking thing. Alright, its domain here is negative infinity to infinity. And its range is negative infinity all the way up to 3. Ta-da! Alright, moving forward. Number 3 here. Use f and g by the following table of values to evaluate the following. That's poorly worded, isn't it? So A is find f of 0. What you're going to do is you're going to look at the table that involves f. You're going to look at the x value of 0 and you're going to return the y. It's 1. C is f times f composed of g composed of negative 1. And let me go old school. We're going to work our way out. G of negative 1 is 3. So this piece becomes 3. So now I'm curious about what f of 3 is. And it's 4. This is g composed of f composed of 0. So f of 0 is 1. So this is actually telling me to find g of 1, and g of 1 is 2. F composed of g composed of 1. G of 1 is 2, so now I need to figure out what f of 2 is, and it doesn't exist, does it? DNE. Because there is no 2 value. G of 1, nice and simple, it's 2. F composed of G composed of 4, again, I like to write old school. I need to figure out what G of 4 is. G of 4 looks like a negative 2, and F of negative 2 is a 0. Alright, part F, G composed of F composed of 7. Alright, so F of 7 is a 6, so now I need to turn around and I need to find G of 6. And G of 6 is negative 4. And lastly, G composed of F composed of negative 2. F of negative 2 is a 0, so I need to turn around and figure out what G of 0 is, and it does not exist because there is no x value of 0. And yeah, that was kind of quick, and I think there's one more. I will be right back. I got 2 minutes, maybe 3. BRB. Alright, on to 7. 7's got graphs, which makes it even worse. Alright, so I'm low on time, so I'm not going to write everything out. What I want to do is I want to find f of negative 4. So this is f. X is negative 4 right here, and it returns a 0. Now I want to take that and I want to go to g. When x is 0, function g has a y value of negative 3. Alright, this one says figure out what the y value on g is when x is 3 first. So when x is 3, the g has a y value of 0. Now do that with f. When x is 0, a y value of 2 is returned. This one's kind of interesting. F composed of 2, negative 2. And we work our way out. F of negative 2 is 3. So I'm supposed to turn around and find f of 3. F of 3 is 1. These are not hard. They're really not. But boy, they confuse kids. G of 3. So G of 3 is a 0. And G of 0 is negative 3. G of f of negative 5. F of negative 5 is negative 3. G of negative 3 is negative 5. Weird, huh? G composed of f composed of negative 3. F of negative 3 is roughly 1.5. Looking over there. Okay? G of 1.5 is roughly negative 1.5. And there you go. Hope you enjoyed. You probably didn't.